Learn high-level system design by coding a YouTube clone. Starting with a basic flow, you'll gradually add 3 key services: upload, watch, and transcoder. This course covers the actual high-level design concepts in practice, including chunking, transcoding, and FFmpeg, and adaptive bitrate streaming using HLS. Kirti teaches this course, and she will help you build a sophisticated video platform and master system design principles.
The files are being generated, chunks or parts. Did you see this happen in parallel? Adaptive Bitrate Streaming. Let's see, the first 10 seconds of the chunk is present in this file. So these are the things that we have coded. I coded YouTube in 6 hours. And it is not just another YouTube clone. We wrote 3 services: upload service, watch service, and a transcoder service. We also added a pub/sub Kafka, and we also added DP PostgreSQL. Now before I get into the details, before I do a code walkthrough and tell you everything, let me first set some context and tell you why and when did I write this code and how you can benefit from this video. Let me begin by reminding you that just clone projects or just simple web dev projects don't work anymore. They are not impressive anymore because the competition has increased so much. You're expected to also talk about system design. So this is a project where we will be doing high-level system design along with the code. And the code that we have written, we have even done transcoding by ourselves. And this code is not easily available online. This is something that, takes a lot of effort to create. This is truly quality content. I can vouch for that, and I take a lot of pride in that. So this is something that you won't find easily, and this is a very different kind of project. Now, why did I create it? This project was part of my HHLD course, hands-on high-level system design course, where we took up 3 projects. One was WhatsApp, second was YouTube, and third was Zerodha. So this is one of the projects that we did in HHLD. Why am I saying I took exactly 6 hours? Because all the code that you're going to see, every single line has been written during the classes. And YouTube project lasted for 2 weeks, which was 6 hours of classes. And every single thing from creating files, creating projects, even setting up environment variables, setting up OAuth, Kafka, everything has been done within the class. Even all the explanation was done within the class. So when I say Kafka, I also explain what is Kafka, how can you picture it, why do we need it, OAuth, what is OAuth, all the setup, all the theory, detailing, everything has happened during these 6 hours. So if you think about it, this code has actually been written in less than 6 hours, maybe 3 hours, you can say half of it. Because I've explained each line of the code at least twice to my student. Now the question might be that why am I making all of this available for free? See, this is a project which is extremely great. Okay, this is awesome. My students take a lot of pride in being part of edu courses. I know that the kind of guidance, the kind of motivation that I provide cannot be provided outside. I know that we have all pushed each other to write better code, we support each other, we solve each other's doubts, and all of that is there. But still, if you cannot sign up for HHLD or if you do not want to do it, I still want to tell you that how you can, start thinking about such a project. That if you take up making your own YouTube, how to go step by step, what are the instructions involved, how you can go through it. And I will also give you the code. It will be available for free, so you can access it. In very simple terms, if you're someone who wants to build a project, you will be able to, because this video will be enough for step-by-step guidance, and it will also give you the code. But if you are looking for more structured, more detailed guidance, then you can still enroll for HHLD. The recordings are available and the course is still going on. We are going to be working on Zerodha. So you can still enroll for it. And recordings are available. You will also get access to the next batches. So all of that is there. The details are there on the site. You can check it out. Actually, if you're a complete beginner, you can still sign up because we have covered end to end. Starting from, in the first few classes, I even explained what is Node, what is the difference between Next.js and React.js, what is Next.js, how to install packages, every single detail that you can think of. We started with AWS, what is VPC, what is subnet. Fast forward, we have done so much, load balancers, we have used so many services now. So all of that was part of the course. But okay, that was like a quick recap that if you want to sign up for the course, you still can. But now let's finally get started and I will tell you how you can approach the entire project step by step. Let's get started. Since a lot of my students are beginners and a lot of you might also be beginners, so what I've done is instead of starting from HLD, you also can do this. Start from the core features. What are the core features? Upload, watch, and transcode, right? So just focus on these core features and understanding everything step by step, and later we'll stitch everything together. So initially we'll focus on how you can upload everything, Then later we will, level up, and then we will do chunking and upload. And after that we will level up and do adaptive bitrate streaming while watching and encoding while uploading. So in the starting, we'll keep things very simple, but most of the code is going to change later. So right now, if you see the code that I am showing on the screen, I am showing Google Doc. Why am I showing Google Doc? Because most of the code that I am going to show in the starting, that is going to change. But if you want to see code also, you can see there are 4 main things that we have written, 3 services. So this is the backend. All of this has been written in Node.js, and client is written in Next.js. So let's see how can we get started. The first thing that you can see is how to play videos on client. So for that, there is a very famous package that you can use on React or Next.js, which is called React Player. So you can use this, and here you can see we are not just playing videos on client, but we did 3 things actually. So when you want to play video, first thing, you can play any YouTube video. So I said, take any YouTube URL and play that using React Player. The second thing that we did was you should be able to stream your video audio. So streaming something like Zoom. So that is why first page that we created, I called it room.jsx, because that gave like a Zoom feel. You click on a button and you can start streaming yourself, both video and audio. You can ask for permission and start streaming yourself. Third thing that we did was that create one S3 bucket. So here you should understand what is a bucket. I explain to my students what is a bucket, how can you create a bucket, how to add a video, just upload manually. And from there you will get one URL. You can keep the bucket public for now, just to see that you are able to play using React Player, and take this URL, and using this S3 URL, you should be able to play the video. So this was the first step that we did. And if you want to see the code, let me show you from here. So this is the first step. This is the package React Player that we use. And you can see I have added 3 main things, right? So this React Player, here I have given one YouTube URL. Here I have given one S3 URL. So I uploaded the day 9 recording of my HSLD class, and I showed them that you can play like this, adding on the S3. Same you can also do, right? And the third thing, you can add a button, and as soon as you click on the button, I've named it call user to give you the feel like of Zoom, something like that. And here what you can do is the URL is the user stream. And how will you get the user stream? Just like this. You can turn on your video audio. It will ask you for permissions and you will be able to play it. So the first step is completely focus on the client side, so that you get the confidence that you can play the videos on the client. So let me just write this down. So the first step was on the client side, that you are able to play the videos. So this is client. So we are done with step 1. After that, what we did was that we created one upload service. So this client is on Next.js. We created one upload service, and this is on Node.js. And here what we did was we created one API /upload, and the main goal of this API was to upload some video or some file to S3. So to keep things very simple, first thing that you can do is upload just PNG. That's what we also did. After that, you can try uploading a small video, like 4-5 second video. So you're going step by step, you're leveling step by step, right? And both this PNG or video, what you can do is you can hard code for now. That just add some file in your backend and try uploading that right now. So this is the first step, right? That create upload service, upload media on S3, and you can test this upload API using Postman. So initially we tested using Postman. So Postman is going to do /upload, and it is going to call this API, and whatever hard-coded file you have, it should be able to upload on S3, and from here you will get a URL that you can play on your client also, and you can save. Then after that, what we did was to level up. Now instead of from Postman, so we'll just remove this. Instead of sending from Postman, we will send the upload request from the client itself. So on the front end, right? So you're stitching everything together. Now over here, after sending the upload request, now here also right now everything is hard coded, right? So the next step that you can do is here you will add one input field for file, and you will add this in the request. In this upload request, you will add the file in the upload request, send it to this backend service, and this backend service will upload to S3. So one entire flow is going to be complete. So you're going to select a file, send it to upload service, and that is going to upload it to S3. So let's look at the code now. So this was the first step. After that, the second step was to create upload service. So in our upload service, you can see I have created one API upload. I have created one route, and the logic is going to be inside of the controller, and this is the controller code. Why I am showing the code in the doc right now is because the code has changed a lot by the end of the project. The link to the doc is again in the description. You can check it out. But to give you an idea, say in our upload service, there are controllers, there are routes, right? So inside your route, you can create one upload route, and here you can create, like right now there's upload to DB, there's complete. So in the starting, we had one upload API. So you can think of something like this, right? And the code was in the controller. So in the controller, in the end, we'll be chunking and we'll be uploading that. But your official code should be in controller, okay? Let's see our controller code. Now to be able to connect to AWS, we are using the package AWS SDK. And this is just to get the file. So right now, as I told you, in the second step, I am hard coding the file on the backend. So this is my hard coded file. And here first I'm just, connecting to my AWS. I'm giving the bucket details, the file name, key, the access ID, all of this, just configuring AWS. And this is my main code. So here I am uploading, and what I'm doing is that if there is any error, I am just logging in and sending the response of 404. And if it is successful, just giving the success response and logging in. That is it. And in the next step, what we are going to do is we are going to add the UI, because right now the backend is hard coded. Now we are going to add the UI. So here on my main page, I've added one component, upload form. And if you go inside this component, you're going to select a file and then send it, right? So for that, there is one input field where you are taking the input of file. And here we are handling the file change. What are we doing inside that? We are just setting the file. And when you want to handle the submit, you can handle file upload. What we are doing inside this is, so our backend server, our upload service is running at 8080 port. So you can just call /upload, and here we are adding our file in form data. We are appending it in file data. You can also inspect and see that file will be going in your network. I'll be demoing everything in the end. Now that in this point, what have we done? We have selected the file from our front-end UI or from our client and send it to the upload request. On the backend, we need to take this file out from our request and we need to send it to S3, because right now on the backend everything is hard coded, right? So that is what we are going to do. We are going to extract file from the request and service and upload that to S3. So for that we are using Multer or Multer, how do you pronounce it? So again we are using AWS SDK, and before our controller there is a middleware that we have added, because there is a single file that is going to be there. So this part is same, but instead of the hard coded file, we are getting the file from request.file. And again, we are just configuring AWS. So the same code has now changed, right? Here now what we are doing, we are taking out the file from the request. And in the upload, same thing is happening, that we are going to try uploading this. And if it is not successful, okay. And if it is successful, good. So now that one flow is complete, that you are uploading from front end to your backend to your S3, and you're able to play that S3 file on your front end, I think you should feel a bit more confident. I saw this confidence in my students. So what we did was, after that, I introduced OAuth. So we'll be doing OAuth in this project. Actually, I had already done auth using JWT in my WhatsApp project, and we had discussed JWT a lot in detail. I'll be creating another video on that as well, so you can refer to that video. I'll add the link in the description. In this project, I have focused on OAuth, which is like sign in using Google. And later we also compared a bit, what is the difference between OAuth and SSO. You can read about it. But here what we will be doing is we'll be focusing on sign in with Google. What you can do is use Next.auth. So if you're doing this, the main thing that you need to understand is that this is happening on Next.js ka server. Now this is the main difference between Next and React, that in React everything used to happen on the client side, but in Next there is also something called server side, and that is why in a lot of places you will see that on the top we write use client, right? So Next.auth is something that we have done on Next.js but server side, instead of writing a completely different service for it, because I wanted you all to understand that you can also work on Next.js server. That is why you can write full stack, full projects on Next.js itself, the front end as well and the back end itself also. So here we are using Next.js server. Here you will have to sign up on Google Cloud Console. You'll have to create your project and set everything up. So once you do that, all the steps are written on this. You can refer to it. You can add your Google provider, and using Next.auth, you can do sign up. So here you can see what you can do is that we have added two buttons. One button is for sign in, and one button is for sign out. And here's a simple sign in, sign out, because we are using Next.auth. Next.auth is amazing, guys. You should definitely try using it. It makes things so much easier. and you can get the data from use session. And this data, actually later in the project you will see that from this data we took out like username and the image, and we displayed that as well, and we made sure that only those who are signed in are able to upload the videos. So this part is very interesting. Just read about Next.auth and try implementing it. And over here, so yes, session provider and all of this is done. So this is what we did in auth, and after this we discussed a bit of theory like SSO versus OAuth. I hope you understand all of that. But now let's get to a very, very interesting part, which is Kafka. Now that we are done with one flow, so we did from front end to back end to S3, and we also talked about auth, right? I think it is time that we start talking about HLD. So that is what we did. So here the first thing that you need to understand in HLD is that uploading is not straightforward. There are more things that are involved, because when you are uploading the video, first thing that you need to do is content filtering. You need to make sure there is no hate speech like nudity and all of that. Secondly, you need to take care of copyright issues. So you need to do all the checks. The third thing that you need to do is transcoding. So while playing the YouTube videos, you must have noticed there are different resolutions, 1080p, 720p, 480p. So while uploading itself, we have to transcode the video in different formats and keep it. So because there are multiple things that need to be done while uploading itself, we need a pub sub. Why a pub sub? So there will be one service that will be responsible for adding to our pub sub. In this case, we'll be using Kafka in our project. And from here, different services can pick up the same message and use it. So here, suppose there is one service for transcoding. So it can consume the message and it can transcode the video. So this is the next thing that you can do, that we also did, that we implemented Kafka. We understood Kafka in details, how it works and all of this. So you can also read about it and just do one basic check just to get started, that push or publish one message, and that message should be consumed by another service, which is transcoding. So till now we had only one service on the backend, which was uploader service. Now we will create one more service, which is basically a new Node.js project, which will be transcoder project. And there we'll just do this key. Yes, it is consuming the message. The entire code of transcoding and all that is going to come a lot later. For now, you just need to be able to see that, okay, Kafka is working and you're publishing to Kafka, you're able to consume from Kafka. Coming to Kafka, so I have added a bit of theory because we had like a bit of theoretical class where I explained what is producer, consumer, broker and all of this. Actually, there's one video that I'm creating on Kafka, a crash course sort of thing. So I will add the link to that also in the description. So you can understand Kafka from there if you're a complete beginner. So as you can see, there will be two services. Upload service we had already written, and that will act as a producer, and there will be one more service that we'll be writing, which will be the consumer, the transcoder service. And here there are a lot of online free solutions for Kafka. One is also Cloud Kafka that I used in demos for HLD batch. For HLD, I've used iWin for all the demos. So you can create services. There are a lot of free services over here. This is no way any promotion. I just found it good, so I'm just using it. As you can see, I've set up one Kafka, and you can see all the configurations. You can set it up in your project, and here you can add topics, you can create topics. So here you can see there's one topic which is transcode. So we'll be producing to transcode and we'll be listening from here. So in both our services, upload service and transcoder service, we have added one folder called Kafka, and this code is common because we're just configuring Kafka. Here we are creating one class, and then we are adding brokers, and then we are setting up SSL, password, admin, all of that. And then we have written the code for produce and consume. Now, although the code is common, in uploader service, this is going to be used, and in transcoder service, so if you see over here, in this one only consume will be used, but I've added in both just to show you. And here if you see, where am I calling? So in transcoder service, in my index.js, and here if you want to see where are these called, suppose let's see in transcoder service first. So if you go to index.js, here I have added the config, and here I'm consuming. I'm consuming what? I'm consuming transcode, and here I'm just logging ki I've gotten data from Kafka. That is it. This consume is called in the transcoder service. Where is the publish being called? In our upload service. So this should be called, right? Produce. Since we have to upload in the upload service, let's see the code for that also. So in the index.js, we'll be able to see that I had added one more route itself, publish. And this is the router that I am using, and this is the actual code. So this will be there in the controller. So over here, send message to Kafka, and here what are we doing? We are just producing the message transcode. So I will run it and show in the end itself everything. So here I am pushing to Kafka from the uploader service, and what is consuming? The transcoder service is consuming. And I've also added all the steps in the doc. So how to set up Kafka, overview, all of this, setup, like you need a certificate and all of this. And you can create a topic on IVIN. And after that, how to configure, produce. So this Kafka.js is going to be there in both the services. And this is the publisher code as we had just seen. And this is the consumer code on the transcoder service. That's it. When we did the first flow from client to upload to S3, we either did for a PNG or for a small video. Now that you have understood auth and Kafka, the next thing that you should be asking yourself is that what is the difference between a simple PNG or a small video, and what are the problems that will happen when there's a huge video. So if there's a huge video, it is going to take a lot of space, and sending it over network is not going to be possible in one go, right? Suppose it's a 1 hour video. What are you going to do? So obviously we need to cut our video into different chunks or parts. So each chunk or part can be like of a few seconds, say 4 seconds, 5 seconds, 10 seconds. You can decide accordingly, right? But you know that you need to divide your video into chunks. Now the question is that where should the chunking happen? So a lot of people get confused with this. A lot of people say that we should be chunking on the upload service side, which is basically over here. So then my next question is that, if chunking is going to happen over here, then how are you going to send the video from front end to your backend also, right? Because if you're doing the chunking over here, first thing that you need to do is be able to send the video from front end to backend. How are you going to do that? So the correct answer is that you should be chunking on the front end itself, sending it to the backend, and which is going to send it to the S3. Now the final thing that we want to do is that once we send these chunks from our front end to backend to S3, finally on S3, what should happen is that all of these chunks should be put together, should be assembled together to a single video, right? Even though we are sending it in chunks, the final thing that we want is a single video, correct? So this huge video, how can we play also? That we will discuss later. For now, let's focus on this huge video, how can we upload it? So that is the current focus. So your next major agenda should be that how can you do chunking on the front end? And then how can you send it from your upload service to S3 such that it is assembled back to a single video. So this is the next thing that we should see. Here I have written different ways to upload data on S3. Here you can see front end to back end to S3 without chunking. So if you do without chunking, it is going to be slow and not efficient. If you do from front end to S3 without chunking, processing like transcoding and all is not possible, right? So a lot of questions come that what if we remove the backend? Why do we need backend? Then how are you going to do all the processing? So this is the answer. Front end to back end to S3 with chunking. This is what we'll be doing. Faster processing is possible, retry, resume, abort, all of this is possible, right? Then there's also one more thing, uploading using pre-signed URLs. This we are not going to discuss right now because you need to understand pre-signed URLs in S3 for that. If you understand that, you would have understood this, right? So next agenda after Kafka, the first thing that we did was send video in chunks from client to server to S3. So right now what is going to happen is these chunks itself will be uploaded on the S3 also. The reassembling is not going to happen. Whatever chunking you're going to do in parts, those chunks will be sent to your upload service, and the upload service will send as it is the chunks itself to S3. So this is what is going to happen right now. So first thing that we need to do is do the chunking on the client side. So this is how you can do. So first thing that you need to see is that what is going to be a chunk size. So here everything is in bytes. So this is going to convert into MBs, and you can mention how big you want your each chunk to be. Suppose you want your each chunk to be 100 MBs. So this is going to be a chunk size. You can find the number of total chunks. You can log it to be sure at how many chunks are there in all of this. And after that, we are going to do the chunking. Now chunking is actually very interesting. This is where you need to understand your algos a bit so that you're used to writing this code. So your chunk index is going to start from 0 till less than total chunks. And you're going to slice your file. You're going to slice it from start to start plus chunk size. So your start is going to keep varying, right? So suppose it starts from 0 to 100. Next time it is going to be 100 to 200, like 101 to 200. After that, it is going to be from 201 to 300 and so on and so forth. And how we were sending the entire file earlier in our form data. Now what we'll be doing is we'll be sending the chunks. So here I am uploading what? I am sending the file name, the chunk, what are the total number of chunks and what is the index of this particular chunk. So in this for loop, what am I doing? These are the number of requests. So this is my for loop. And inside the for loop, I am going to keep uploading the chunks. So earlier I was sending one file. Now this same request is going to get called how many times? The number of times as their chunks, right? I can also show you in the code. So this is my client. In upload, there is one page.jsx. Obviously, this code is like the final code, but this is actually the same thing. So if you want to see the for loop, you can understand from here. We are slicing our file from start to start plus chunk size, and then we are sending it in form data. So this call is going to happen how many times? How many times this for loop is going to run, the number of iterations. Now that we have sliced our file into chunks on the client side, our backend service should know, our upload service should know that now I'm not getting one single file. I'm going to keep getting chunks. So that is the next thing that we'll be doing. So this is just the div. So this is where the front end ends. Now in the backend side, so in our route, instead of, you remember there was this upload.single file. Now instead of single file, there are going to be fields. There's chunk, there's total chunks, and there's chunk index. And our upload file to S3, the controller is going to upload it to S3. So same thing. But right now what has happened is that the chunks got uploaded to S3. Now the thing is that what we used was s3.upload, right? If you remember in our upload form, how were we uploading? s3.upload. So if you want to see the controller code, let's go back to it. So we were using AWS SDK and we were doing s3.upload, right? So it is going to upload one by one. Now what is the problem is that all of these chunks are going to get saved separately on S3. Now AWS SDK gives us a very cool feature. So instead of uploading these chunks one by one to completely different files, what we can do is instead of s3.upload, we can use something called multi-part upload, which means that we are going to send it in chunks and S3 is going to reassemble it together. So whatever we did till now was what I had done in the week 1 of the project. So our project was divided into 2 weeks, right? It was a 2-week project in HHLD. So first week is what we did so far. Second week, this was the agenda. First agenda was multi-part upload from backend to S3. Now, what we have done currently is from front end to backend, everything is getting chunked, and then the chunks we are uploading to S3. Right now, for the first part, you can forget about the client. Just take any file on the backend, slice it in the backend itself, just for easy, just to be able to understand. Slice it on the backend itself. But what you want is that on the S3 side, it should be put together and you should be able to play the file together. So for that, we are doing multi-part upload. So if you go to the docs, actually I've added the link to the docs and the docs is just amazing. I'll quickly summarize it for you, but you can go through it yourself, okay, since you're making the project. But the multi-part upload process is divided into 3 steps. One is the upload initiation, the second is the parts upload, and the third is the completion. Now, initiation is when you're going to tell that, I'm going to initiate a multi-part upload, and then it is going to create a upload ID for you, the S3, and it is going to give you back. Now, after this, whenever you're going to upload the parts or complete the upload, in that you're supposed to send this upload ID so that S3 knows that, okay, all the parts, all the chunks that I am getting or the completion of the upload request, all of this is corresponding to this upload that you initiated. So it is just going to generate an upload ID and give you. So the upload ID is generated where? In the initiation part. After that, there is one parts upload. Here you're going to send all the parts, and in the response of it, you're going to get an entity tag. And in the multi-part upload completion, what we are going to do is you are supposed to send all of this information, that how many parts were there, and with that, whatever entity tag it had returned you, that you need to respond back. See, here it is written that when you complete your multi-part upload request, you must include upload ID and the list of both part numbers and corresponding E tag. So you're supposed to send 2 things, part number and E tag values. Let me show it to you in terms of diagram also, so it will be clearer. So in simple terms, multi-part upload, S3 expects 3 requests. One is creation, second is upload parts, where you're going to upload all your parts, and the third is complete multi-part upload. What S3 is going to do is it is going to put all of these parts together. It is going to reassemble it together into a single video. So let's see in the diagram so that it is further clear. So what we were doing till now was s3.upload. Now we are going to try something called s3.multi-part upload. Right, so this provision is given by S3 itself. So it is there in AWS SDK. We are using the package, right? What S3 expects is that we will send 3 requests. the first request is going to be initiation request, that we are going to initiate the upload. So in the request, we will send that, okay, this is the file name, this is the key and all of this. And in the response, we will be getting what? We will be getting one upload ID. And in the next, both the requests, we have to send this upload ID in the request. So the next request is upload part. So here we'll be sending a lot of parts. So suppose there are 100 parts, or suppose there are 200 parts, how many ever? 1000 parts, you're going to upload that. And in the request, along with your part details, like, what is the part number, you will be giving your upload ID, that this is my part number and this is my part ID. And in the response, corresponding to every part number, you're going to get something called E tag, which is entity tag. So in the end, what is going to happen is when you're going to send the request of complete upload, what happens is you send an array. And in the array, you send what? Part number and E tag for every single part. So like this, you like suppose there were 1000 parts, you will send the array and you will obviously send the upload ID itself. So this was going to be there in your request. And finally, in the response of this complete upload, you're going to get one final E tag, which is going to be the tag of this entire upload, right? So earlier you were getting E tag for every response. Later you will get one final E tag. Also, just for further clarity, every E tag is going to be different because it is for all the parts, right? And this E tag will also be different. So we are going to be implementing the code for this. So we need to write 3 APIs on our upload service. We need to make the 3 API calls from upload service to S3. Now, to make things simple for multi-part upload, earlier what we had done was that we were doing chunking on the front end and we were sending it to the backend and we were sending the chunks itself to S3, right? So this was how we started. So this was the step 1. Now in step 2, right now we'll just forget this. We'll forget it. And what we are going to do is that we will do the chunking on the backend. We are going to hard code our file right now just to be able to test this multi-part upload. So just to test multi-part upload, we are going to hard code the file, chunk it over here and send it to S3. What is expected is that S3 would have reassembled this video and created a single video. So we want that whatever chunks we are sending from a backend upload service to S3, it would have reassembled it. This we should be able to play on the client also. After this, what we will do is we will do the chunking on this. These chunks we are going to upload to S3 using multi-part upload only. And then this S3 would have reassembled it to a single video. So we want to go steps by step. So for the first step, what you can do is you can just hard code it and send it. And after that, you can do the chunking on the front end, which is the correct way, and then send it. So in order to do this, what you can do is you can test using Postman. So step 1 is multi-part upload from backend to S3 using a fixed file. So fixed file. So what do I mean by fixed file? We are fixing the file on the backend. So we have given the file path and we are seeing if the file doesn't exist, we are not doing anything. So we are going to be testing this using Postman, right? So here this we have done earlier also. We just configured AWS, that's it. And now you can see inside this try, there are basically 3 requests. So this is the first request where we are creating the multi-part upload. So this is returning a promise. And from this promise, if you see, we are getting what? We are getting the upload ID. So multi-part params.upload ID, right? So whatever we are getting from the response of the first one, the initiation one, we are getting this. And from this, we are getting the upload ID. Just try it out yourself. The documentation is very much clear. You can try it out, right? And again, same chunking we are doing. So there's a for loop. So inside this for loop, we are making another call, which is upload part. And here, if you can see, I am saying upload part. And in the response, in this data, there is something coming E tag, right? So we have created an array. So the array is empty. So we are storing all the E tags of the uploaded parts in this array. So here you can see I am pushing the part number and the E tag. Why? Because while completion over here, I need to send it. So here I can see that I am passing this parts. So uploaded E tags, this array, I am sending it in the end. And in the response, I'll get that, okay, I've uploaded it. So this is how you can test multi-part upload from backend to S3. But in reality, what you should be doing is you should be doing the chunking on your client side. So we'll do that. And for this, by the way, for multi-part upload, you will change your router also. And you can set your COS permissions on bucket and all of this. And after that, what we need to do is we need to send the chunks from front end to back end in sequence and then multi-part upload to S3. So Front end is where it should happen. And this code, I can show you the code also because this is the final sort of code. So this is the client side of code. So in upload, what we have done is in our handle upload, if you see, there are 3 paths, right? So from front end to back end also, now there will be 3 requests instead of just 1 request. So here, when there's a button and when we click on upload, so in our handle upload, what is going to happen is 3 requests are going to happen to backend. So the first request is going to happen is that I have called as /upload/initialize. So if you see on the backend, there will be 3 routes. Let me show that to you. See, for initialize, there is 1 route. So this is where we will do the create multi-part upload. After that, there is just one / route, which is like upload the chunk. And here we are expecting chunk. Now initialize, what is going to happen is we are going to expect the file name, the title and all of that. That is why something is going to come in the body, but it is not a file. So Multer expects you to give upload.none. And here there is going to be a chunk, and here there's like the third request is complete, right? So on our client side, what we have done is 3 requests. So the first request is upload initialize. And here what are we giving? Just the file name. Here whatever selected file is there in our input field, that name we are giving. And this is the first request that is going to happen. And from here, what are we going to get? From the response, we are going to get upload ID. And once we have this upload ID, we are going to use that in the next 2 requests. So this was the first part. And after this, in the second part is where we are going to do the chunking. So here we are doing the chunking. The code is same that we have seen earlier. So this was the first call. And in the second call is when we will be doing the chunking. So this code we had seen earlier also. We were seeing earlier also that upload call is going to be done so many times. So whatever is the selected file, we are slicing it. And in the form data, we are adding everything. Here you can see that I am creating an array of upload promises. And in the end, I am just pushing all of them. So in short, we are just uploading the chunks over here. Now after that, there is one more thing that is left, which is completion. So in the upload complete, we are sending that, okay, this is the part. So these are the total chunks, upload ID and all of this. And if you want to see the other side, the backend side, so there are 3 requests, and let's see the controller as well. I created another controller so that you can compare that what was the first thing. So earlier we were just doing s3.upload. Now we are doing multi-part upload. So now in multi-part upload, there are 3 functions. You can obviously move them to 3 different files, but for now I've just kept 3 in the same file. So there is initialize upload. In this, we are configuring all of this and calling create multi-part upload. There is another one. And by the way, for each one, we'll be sending the response now, right? Because 3 different requests from front end to back end. And the second one, we are uploading the chunk. So here we are going to send the upload ID, the part number and all of this. And in the third one, we are going to be sending the complete upload request. So this is how you can do multi-part upload. So we are done with the first 2 steps. We did multi-part upload from backend to S3. Like earlier, the file was fixed. After that, we sent the chunks from front-end to backend in sequence, and then we did the multi-part upload to S3. Now what we are going to do is send chunks from front-end to backend in parallel. So what do I mean by that? So if you notice the difference, let me just tell you something. So in the client code over here, in the for loop, if I keep adding await, okay? So await means what? It is going to wait for this to happen. So while one chunk is getting uploaded, this is in the second request, by the way, when we are uploading the paths, right? So from our front end to back end, what is going to happen is, because we have added await in our for loop, it is going to wait for one part to upload, and it is going to happen one by one. Versus what I can do is create an array of promises. And here, instead of adding await, what I'm doing is I'm just keeping the promises over here. And after the for loop is over, after this for loop is when I am saying that await all the promises together. So what is going to happen is from front end to back end, instead of sending it one by one, you can send them in parallel. Now the question that can be asked is that what if you're putting a too much load on backend? Now for that, you can also do load balancing because there is upload ID, right? So from that itself is enough for you to understand that this is part of which upload. So if there are way too many upload paths, you can still handle that, but this will definitely make things efficient. So if you notice over here, sending chunks from front end to back end in parallel, create upload promises array, and over here you can keep pushing them and you can await all of them together. Now that the first 3 points are over, let's do a quick revision. So you did chunking on your client. Then you sent your chunks to your backend, and then you did multi-part upload to S3. Because the multi-part upload expects 3 APIs, you created 3 APIs from front-end to backend also, and from backend to S3 also. So there were 3 calls from front-end to backend and from backend to S3, right? Initiation, upload parts, and then complete upload. Now that upload flow is clear, it's time that we start talking about watch service. So here we are creating the watch service. And also we talked a bit about, that S3 right now, whatever we have been using is public. You can make it private and you can access using signed URL. So you can play around with that. You can get the signed URL. So this is just something that I wanted to show. You can skip it if you know about signed URLs already. The main point is that create one watch service, because from watch service also what we are going to do now is that we are going to attach a DB and we are going to add all the video details in that DB, and from the watch service we are going to watch that. Let me explain using the diagram. So what we have done right now is that on our front end we are doing the chunking. We are sending it to our upload service and then we are sending that to S3 using multi-part upload. Now first thing that we did was created one more service, which is watch service. Okay, then we created one more database, which is PostgreSQL, and here we are going to be using ORM Prisma, and we are going to do what? When we do upload, we are not just going to upload the video on S3, but after completing the upload, basically in the third request after completing the upload, in our PostgreSQL we are going to be adding some metadata, like for example our title, our description, our author name, and because we have finished the upload, we would also have what? We would also have S3 URL in this, right? After completing the upload. So we can add the S3 URL as well. So what are we going to do? We are going to first do the upload to S3, and after the completion, we are going to get the URL. After that, we are going to call this PostgreSQL and we are going to add the metadata, title, description, author, S3 URL. So we can send the S3 URL to the PostgreSQL. And then what we are going to do is we are going to add a route in watch service to list all the videos. So right now we are going to be using the same DB itself. So we are going to do something like get all videos. And our client will be able to, like from our home, so basically YouTube home is going to give all the videos, right? So there will be like a list of videos on our client. So this is the next thing that we are going to do. And let me tell you a step further also, because I can walk through the code together. Once you can watch all the videos, what you can do is on this screen itself, you can add a button for upload, right? But who can upload? Only signed in users. So we have already done auth, right? So we'll just integrate it together, and what we'll do is only those who have signed in can upload and those who have not signed in cannot upload. So there will be either sign in button, or there will be like sign out and upload button. And you can also put hello name and image and all of that if the person is signed in. So this is the next agenda. As I explained, after getting the list of the videos, what you can do is add the front-end code firstly to list all the videos and to play the videos and all of that. And only authorized users should be able to upload. So let's see the code for all of this. And I promise I'm going to show you the demo. It is going to be awesome. To create video metadata DB, again, we are using Postgres. Again, we are using the free solution from Ivan itself. So you can set it up. You can set up your database. So here I had set one HHLD class during the class and we were using that. And interestingly, YouTube actually uses Vitis, which is not free. Otherwise, we would have used that. So you can read about Vitis. Vitis is actually great for horizontal scaling, even though it is a relational database. And so I have listed out the differences between Vitis and PostgreSQL. And we'll be using Prisma for ORM, which makes things very much easier. So instead of writing queries, you can treat that like your code itself. So like how you create table, you basically create an object, something like that, while creating the entry. So the documentation of Prisma is just awesome. It is very detailed. So all the steps that I've added over here are taken from the documentation itself. So you can go through that in detail. And we are creating the metadata and stuff. Coming to the code, within upload service itself, if you see I've created another folder DB. Within that, there's db.js, just named simple itself. And here we are doing add video details to DB. Where are we doing all of this? So when we do Prisma init, you can see the commands are written in the doc and it is also there in the Prisma documentation also. There's one file that is created, which is schema.prisma. And here it creates all of this for yourself only. You just have to create a model. So here we have created the model. So ID is an integer and we are auto incrementing it. There's title, description, author and all of this. And the migrations are created by itself. So, and if you see in env, there's database URL that is added. And how have I set this up? From my Ivan, right? So I have created a model over here. And over here, what I'm doing is prisma.videodata.create. So you can see creation becomes so easy. It is like code only that you're writing. So you'll be adding data, title, description, author, URL, and so on and so forth. If you want to see your data in UI version, so I have installed something called PG admin, again, something I found for free. So go to servers. Here you can see HHLD demo, and then here you can see table video data, right? So here we had created a database called HHLD class. And if you go over here to video data, here you will be able to see the columns and all. Let me actually just go to the query tool and let me write a query, select all from video data. So this is whatever data you're going to see. We have created everything during the class itself, and whatever data like during the upload, watching, I've created everything during the class. So yep. So these are the random names that I added, and you can see the URL. So when we uploaded, we got the URL and then we uploaded that over here, and I will show it to you running in the end, but you can see the database like this. So this is what we just saw. You can add model in Prisma schema, and db.js, we just saw this, right? We can add video details to the db, you can create, right? And you can test using Postman. How you can test using Postman? So for this, what you can do is, so if you come over here, in upload ka controllers, here we had seen 3 functions, right? Initialize upload, upload chunk, and complete upload. So just to test that uploading to DB is working fine, I've created another route, and here I am testing upload to DB. But initially you can test via Postman, and in the request you can send title, description, and author, right? And URL as well. So let me show you from Postman also how your request can look like. So whenever I create APIs, my usual practice is that at first I'm going to test from Postman, make sure that everything is working fine on the backend, and then add on the front end. So this is what I have done. I've just tested over here, upload to DB, title, description, author, URL. So that is why I'm getting all of this in the request, and then I'm adding the video details to DB. So you can do the same. You can test that everything is working fine on the backend, you're able to upload. And after this, what we can do is we can come back and write the front end code. So I've also mentioned the Postman body and the router that you can add. And over here, what we're going to do, we are going to send the video details from the front end during completion of upload and add it to the DB. So on the front end itself, if you remember, there were 3 calls that were happening, right? So if we go back to the client and source and upload ka page.jsx. So if you remember, there were 3 things that were happening. First was the initiation, second was the uploading of the parts, and then third was the completion. Now in the completion, if you see, these things I have added now. So this was not needed like before. Now we are going to be adding title, description, and author. And now what I have done is that in my form, I have added more input fields, not just file, but there's also an input field for author, for description, and for title. So this is how you can, keep improving your project step by step. You can keep adding the things. So here we have added title, and then we have also put a check that title and author cannot be empty. They are required. And then after that, in the completion, you can add title, description, and author. Earlier, there was just file name, total chunks, and upload ID. And later we have added all of this. And you can just add the input fields. I think we are ready to see the upload flow, at least from the front end to the backend. Let me finally show you how it is working. So in order to run, I have created 2 terminals, one for client. So I can run this using npm run dev. So it is running at 3000, and upload service I'm going to run using nodemon and dev start. So this is running at 8080. Yep, at 8080. So now if we go into complete upload, so finally in the end, what is going to happen is that we are also going to be uploading to Kafka, right? So right now I'm commenting this because we have not discussed this so far. We will be adding video details to DB and we'll be uploading, right? So we should be able to see it in the DB though. So if you want to see what all things are there in the DB, if I just run this again, so you can see there are 7 entries in the DB. And if you want to see S3, this is the HHLD classes. And if I refresh this, there's nothing. I've deleted everything, right? So we are going to try uploading. But before we go ahead and see the working code, there's one thing that I want to talk about. So here, since we are doing multiple things, add video details to DB, push the details to Kafka and all of this, and we are also completing the upload. So there are 3 things that are happening, right? Completion, adding video details to DB, and putting to Kafka, which we will do. But okay, 3 things are going to happen. Now you should be asking questions like, what if one of them fails? How are you going to handle it? Now, we have not gone into that level of detailing in this project, but that is something that you should be talking about. For now, you can just put everything into error. You can catch the error. But ideally, what you should be doing is, if addition to the video DB failed, then you should be talking about what is going to happen on the video that is there on the S3. Are you going to show a pop-up to the client and ask the client to add the video details again? Or what is going to happen? How are you going to handle all of this? So these questions should be coming because you're talking about HLD. But because right now we are keeping things simple, now I'm going to go to localhost 3000. And this is how the UI looks, title, description, author. I've kept things very, very simple right now. And if you want to see the network tab, let's do that. So let's go to the network. So currently there is no call, there's nothing on the console, right? Suppose I want to just add YouTube, HHLD, and description is like with, suppose, Kirti Purswani YouTube channel. And suppose author is Kirti itself. And we are going to choose a file for upload. And let's say it is the day 15 recording of my HHLD classes. And I'm going to try uploading this. Okay. And let's see the network. This is going to be interesting. So did you see this happened in parallel? So first request that went was initialized. And you can see all of this happened for parallel. Some is happening already and some is taking some time, right? The upload. This is basically upload paths that is happening. And why is it happening in parallel? Because promises we had not awaited. We had just created one array and we were awaiting it together. So that is why the upload from front end to back end is happening in parallel, right? So there are so many chunks in this file. This is a pretty big file. It's a 2.5 or 3 hour class, right? So after 2 hours, we do chit chat and all of this. So it might be like 3 hours of Zoom recording. So if we see the initialized one here, we are just sending the file name and we are sending it in form data, if you remember. And in the headers, you can see everything. So you can see upload paths is still happening. Some chunks are uploaded, some chunks are still happening. And you don't see any call after this, right? So after all the paths are uploaded, there's going to be one more request. What request is going to be? It is going to be the complete request. And if you want to see what is happening on the backend, so you can see the backend terminal as well. You can see that the data that we are receiving back, there is an E tag, right? So you can see there's an uploading chunk that is happening. So we started from over here. Initializing upload was the first thing. It got the file name from the request, and then we got what in the response? We got the upload ID. So in the corresponding request, we would have sent this upload ID. And you can see a lot of requests are coming in parallel. Why are they coming in parallel? Because we added it in front end. Now you can see the E tags are different for each chunk and it is happening. So it is still happening. It takes a lot of time since it's a big video. So you can see, right? And if you want to see what is the chunk number, also you'll be able to see. If I see the request over here.
A few minutes later.
So you can see we are at the final few upload chunks. So final, I guess 3 are left. Let's see. And as soon as this happens, there should be one more request that goes. Let's see. Let's wait for it.
A little longer than a few minutes later.
All right, we waited for a couple of minutes. Let's see the console as well. So you can see so many upload requests were called, right? And over here, you can also see upload successfully message that came because there was the final request that went, which was the complete request. And if you want to see over here, completing upload is also there, right? And in here, you can see the final E tag that is there and the final URL, and this URL should have been uploaded to the database. And if you remember, there were 7 entries and the ID that got generated because we had added auto increment in our schema, right? So the ID is 8. So if we go to our database and if I run this again, so you can see this, right? So our data got added to the database. We were able to upload in chunks. And now let's check our S3 as well. So if I come back over here and if I refresh, there's a day 15 recording. And I can actually play it. We can open and we can hear. So, okay, I don't want to hear myself. I'm going to mute and play. So this is the recording of our HHLD class. So day 15 class. But yes, so we did one upload request from our front end. We were able to add to the DB. We were able to do chunking. But wasn't this amazing? What we just did was we added the video from the front end from our client. We were not able to just chunk it on the front end, we were able to send it on the back end. The back end then did multi-part upload to the S3 and also added the details to our PostgreSQL. If you think what you just saw was very cool, just trust me and wait for it because things are going to get even more cooler, a lot cooler in fact. So let me just show you the code. You have already seen this. I've just added log completing upload and in the request body now title, description, author is coming. And after completion of multi-part upload, we did add video details to DB. So you already saw the code for this and you saw that I got the URL if you just want to see what I'm talking about. In my complete upload over here, I am getting the URL from over here. So let me just open word wrap, and over here you will be able to see upload result .location, because the URL we are getting from the completion of the upload, and that URL I am sending to add video TTS to DB. So this is it. Now that we have understood the upload part very nicely, let's come to our watch service and let's work on that. Again, our watch service needs to be connected to our database, right? Because we are going to work on a URL where we are going to see our YouTube home and where we will be able to list down all our videos and play them. So that is what I'm going to do over here. In my watch service, I'm creating an API get all the videos basically. So over here, what I'm doing is writing a simple Prisma query. So there are many ways of writing this. We could have used the metadata and wrote this, but just wanted to show that you can also do query raw over here, and you can try this out and we'll get all the videos over here. And you can test using Postman, and after that you can add the front end code. So on the front end code, we are creating another page, YouTube home, and we are again doing the async request to get all the videos, and we are going to do this in the use effect. That means that as soon as the app is going to load, that is when we are going to get all the YouTube videos. And if you want to see how to do that, let me just show you the client code. So over here in the page, just to show you, I added upload form right now. Now what I'm doing is adding YouTube home. So YouTube home is the new page that I've added. So if you go over here, YouTube home, set video, set loading. So initially it is going to say it is loading. And if it is loading in the between, it is just going to say loading, like in the middle of the screen, it is going to say like this. And once it is done loading, it is going to run, right? So upload service I had stopped. Let me just run it again. And let me run the watch service as well. So we are going to go inside the watch service and we are going to run it again using nodemon. And this is also running. And this is running at 8082, and let's see if our request was going to 8082 itself, so that everything is working fine. So let's go to our YouTube home and let's check the request is going to 8082. Obviously I should be putting this to environment variables, but this is just like quick demo. I had done all of this in the end of the WhatsApp project, so I wanted to hurry in this project and focus on the other thing, so I've written like this. Okay, and if we refresh this, so you can see loading, and you can see all the videos have come, including the ones that we just added. Can you see YouTube, HHLD, and summer camp? And you can actually play all of this. This is pretty cool. Now these things that you're seeing is like because you're seeing the final project, but yeah. So I know the UI is not so good, but this is enough. And this is all during the classes that I have written. So whatever was the best we could do, we have done. So this is how we added route in the watch service to list all the videos. So this was the backend part. So here we just did get all the videos. And here was the front end part, which I just showed you, right? Videos and loading, and we just saw this also. After this, the sign out, sign in part over this, what I'm talking about, right? Over here, you can see an edge because it is HHLD with edu courses and all of this. So how can we add that? So if you remember, I had told you about Next.js, right? And use session, sign in, sign out. So I had told you that you will be able to access data anywhere and everywhere. And why I'm able to do that is, let me show you the code. So in the client, if you look at the layout.js, I have wrapped all the children within session provider auth, because of which the session is available to all the children. So that is why what I've done is in my YouTube home on the top. So if you notice over here, on the top, I have added one very simple navbar, right? So I've created one navbar over here. So that is a new component altogether. And if you go over here, I am able to get data using use session over here. And I am going to do what? Once I am able to sign in, should be able to go to upload, right? And I have added sign in, sign out buttons, and here from the data, I'm able to get the username and the user image. So right now I didn't have any image, so it returned H by default. If I would have had any proper image, it would have returned me that, right? So now let's come over here and let's try this out. So if I sign out and if I sign in, you will be able to see that I do sign in with Google. And here now I get the upload button, and if I go to upload, I am able to come over here, and the rest of the flow you have seen, right? So this is sort of a more complete flow. Now there are a couple of more things that you can add to your project. Like for example, if I am signed out and if I try going to upload like this itself, I should not be able to go. But right now you'll be able to go. So these small things you can keep adding because I had written all of this. Because I had done all of this during the class, I have not done this level of checking and changes. And even this, you could have lazy loading, pagination and things like that. For now, it's a simple sign in, sign out, able to upload, able to get the entire flow. So if I go to upload and if I upload from here, the rest of the flow, you know about it, right? It's time to finally move to one of the most interesting things, which was actually the last class of the YouTube project that we did. So all of these things are done, and now it is time that we come to one of the most interesting parts of the entire project, which is adaptive bitrate streaming. So you saw how we started step by step, started from just seeing one entire flow to understanding Kafka, understanding Postgres, adding one ORM and doing all of this. Now it is time to level up one level further, and we are going to be talking about adaptive bitrate streaming. So for the HHLD students, what I did was we discussed a bit of theory, resolution, format, bitrate, what are resolutions, talked a bit about TCP, UDP, WebRTC, RTMP, what is HLS, what is Dash, and all of this. And then we got to finally the code. Let me first quickly explain to you what is adaptive bitrate streaming. So you must have seen on YouTube, and I'll show it to you also, that when you play a video, sometimes what happens when the network is good, the resolution, when you have set the setting to auto, the resolution sometimes keeps changing. So you must be watching something at say 720p and the network connection gets better, it might switch to 1080p. Or if the network connection becomes worse, it might switch to 480p or 320p, right? So what is happening actually is that each video, when we divide it into chunks, what we have on a backend is that each video ka chunk, now that chunk also is saved in different resolutions on our backend. So if this chunk is there, this chunk is saved at 320p, 480p, 720p, 1080p, and similarly for all the chunks. So what happens is, suppose over here we detect that network connection is actually worse. So the next chunk that is going to come with a lower resolution. And suppose over here we realize that, the network connection is now better, the bandwidth is better. So then after this, what is going to happen is the resolution is going to improve. So this is called adaptive bitrate streaming. I have covered this in 2 other videos as well. There was one video where I was explaining adaptive bitrate streaming to my father. And there's one more video where I've covered the HLD of YouTube with Harkirat, where we did an entire discussion. There also we have discussed this. So I will link both the videos in the description. You can check them out. But I hope you have understood what is adaptive bitrate streaming. So as the network connection changes, the next chunks that are going to come from the backend, that are going to come from the server, are going to change accordingly. The resolution of those chunks is going to change accordingly. So obviously what we need to do during upload is that we need to transcode each and every chunk into all the solutions, right? So there are 2 things that we need to do. One is during upload and one is during streaming or watching. So during upload, what we need to do is that for each of these chunks, we need to convert them to all the possible resolutions, and all of these possible resolutions we want to upload to S3. And who is going to do this? Which service is going to do this? Yes, transcoder service. So if you remember, we had added one Kafka. So the uploader service was adding some message to Kafka, and then from Kafka, transcoder service was consuming this message, right? So while completion of our upload, what should happen is that uploader service should put all the details to the Kafka, and transcoder service is going to pick it up from Kafka and then process and then upload it to S3. So this is one thing that we need to do. Second thing that we need to do is during watch, right? Because now, everything is available for us to be able to have adaptive bitrate streaming. But how are we going to do adaptive bitrate streaming? So for that, there are 2 solutions. One is HLS and the other is Dash. So this is going to happen where? This is going to happen on the client side. So let me show you the difference between HLS and Dash. There's a bit of theory that I had added on the doc. So let me quickly explain that to you. If you see the doc, I have added a quick comparison of HLS and Dash. See, both are adaptive streaming protocols used for delivering multimedia. The only difference is that HLS was developed by Apple, so it is actually easier to use it with iOS devices, and Dash is an open standard developed by Microsoft, Netflix, Google, and all of this. So in this project, we'll be using HLS, which is HTTP live streaming. But you can also use Dash, which is dynamic adaptive streaming over HTTP. Let me tell you that the concept is essentially the same thing, just the file extensions and all are going to be different. One very important file that you need to know about when we're talking about adaptive bitrate streaming is the manifest file. Now, before explaining all of that to you, let me actually show you how things are working. Let's actually run it and see. So for now, what we are going to do is forget everything else and just see our transcoder service. Because in our transcoder service, what we had written so far, that we are just consuming the message from Kafka. It's time that we see the actual code of transcoding, right? So let's go back to our code over here. So coming to the transcoder service in index, what I have done is just to test right now in transcode, I'll be commenting this because this is the final one that we'll be using. For now, we'll be using convert to HLS. And what is happening inside this is if I just go to this convert.hls in HLS folder. So here is where the actual transcoding is happening. For now, for demo, what we are going to do is test this using Postman. And what video are we going to transcode? There's one test video that I have added, test.mp4. We are going to be transcoding that. And we'll see that the output will actually be generated. So there's a for loop over here that is going to, generate the chunks in all of these resolutions. So there's an array. So the code is also extensible that if you want to add more resolutions, you can add them. If you want to remove the resolutions, you can just remove from the array. And what we are going to do over here is mention the video bitrate, audio bitrate. I'm going to go through this. But for the output, what it needs is an output folder. So I'm going to create another folder inside this, which is going to be output. And inside this is where the files should come. Right now, you can see there's nothing inside output, okay? And right now, we were playing only with 2 services and 1 client. Let's create another one for transcoder service. And over here, let me just run it. And so it is running at 8083, but it is also listening to Kafka. So for now, just to keep things simple, let me just comment this out so that, the Kafka messages stop coming and it just loaded and it is running at 8083. So what we're going to do is go to Postman and run this. So we got the response immediately, but let's see what is happening in the backend. So can you see this getting generated? Can you see something is getting generated? Yes, can you all see this? This is awesome, right? So these files are getting generated by itself. Can you see it? So it is presently getting generated at 1280 by 720, right? So what are the 3 resolutions that we had given? Let's see that. So let's go to the transcode code. We had given 3 resolutions, right? 320 by 180. So these are the first resolutions and there was a master file for this. Then there was another resolution, 854 by 480, and then there was another master file for this. So all of these are the chunks. And then there's another one for 1280 by 720. Then there are the chunks for that, and there's another master file. And then there's this final master file. Now, what is this? What is happening? Let's see a bit of theory. So what is happening exactly is that M3U8 is the playlist file which is containing the URLs and transport stream files containing the actual media segments. So what we did, whatever we segmented and transcoded, that is saved in this TS. So this TS is nothing but small chunks. But what we need during streaming is one place from where we can read that this chunk in this format is present where. This chunk in this format is present where. So this is what it is telling. This particular master file is telling, let's see, the first 10 seconds of the chunk is present in this file. Then the next 10 seconds are present in this file. Then the next 10 seconds are present in this file. So you can see it is getting generated by 0, 01, 02, 03, and so on and so forth. So there is one master file for this resolution. Then there's another master file for this resolution. So again, you can see that the first 10 seconds are present in this chunk. These 10 seconds are present in this chunk. Now you must be thinking that, Kirti, where did we give 10 seconds, right? So we have given that in our code. So if you see over here, we have given the HLS time should be 10 seconds. So if you change this, your chunk size, the number of chunks and all of that is going to vary. Let me just show you once more. So if these are all 1280 by 720 ka chunks, okay? And if you come over here, this is the manifest file for that. So the first 10 seconds are present in this file, the next 10 seconds are present in this file. Now this is for each resolution. Now you want one master playlist, right? So if you see over here, so one is segment, then there is master playlist, variant, all of this is there. And after that, what you need is one master playlist. What is master playlist? So these were the smaller playlists that we had created. And what is there in the master playlist is, see, this resolution ka playlist file is this resolution ka playlist file is this resolution ka playlist file is this. So essentially, when adaptive bitrate streaming is going to happen via HLS, what is going to happen is that it is first going to come to this file. And then it is going to see that, oh, network connection is good. Let's see that, okay, we can use 1280 by 720. let's refer to this manifest file. And if we are referring to this manifest file, it is going to start getting the chunks from over here. Then as soon as the network connection is going to go worse, it is going to say that, oh no, I need, the ones with the lesser resolution. So it is going to say that for this bandwidth, like, for this resolution, which is the playlist file, then it is going to go to this playlist file, and then it will get the chunks for that. So like this, it will keep doing what? Adaptive bitrate streaming. So M3U8 is the extension and TS is the extension for HLS. When it comes to Dash, the extensions are going to be MPD and M4S, but it is essentially the same thing. So what we have done so far is that we just did one testing for transcoding. We sent the request from Postman and it was able to transcode, right? Now that you have understood that what is exactly happening, the manifest files are getting generated and transcoding is happening, let's look at the code at how did we write the code, right? So we are using two packages over here. FFmpeg is very common for transcoding. You can read about it. Again, all the URLs and everything, all the links are added over here in the doc. So FFmpeg is very famous for transcoding. And what we have used is its binaries. So these binaries have come from FFmpeg static, and we are actually encoding using this. So this package expects you to have binaries. You can either download your own binaries and set everything up, or you can use this for getting the binaries. So this is what we have done. And over here, this is my file name. And okay, so you can see these file names that are getting generated, right? .ts and .m3u8. How did this happen? So we are actually generating these file names, and how that is happening is that whatever is the file name in that, from dot, I am replacing it with underscore. So test.mp4 became test_mp4, and then underscore resolution. So underscore resolution, and then M3U8. So this is for M3U8. And for the segment file, what I have done is that after all of this, I am adding this 00, 01, 02, 03, and so on. So that is how I am doing this. So after I've generated the names, what I'm doing is in this for loop. So this for loop is for every resolution. So if you remember, in this array, there are three things, right? So for every array, what are we getting is, we are getting resolution, video bitrate, and audio bitrate. So here you can see that I'm generating the output file name, segment file name. And then what I'm doing is I am actually doing the transcoding. In FFmpeg, this is the output options that we have given. We have mentioned that H264 codec, AAC for audio, video bitrate, audio bitrate, resolution, and this is the time. Now this is usually used for live streaming and all that, so I'm not going to go into details right now. And this is the output file name that where it is going to be there, and then you can have your error and all of this, and your entire. So as you go through this, what you have done is you have created one array. And as you keep generating these TS and these M3U8, you keep adding them to this array push variant playlist. So what is the resolution? What is the output file name? Because what is going to happen is that you need to create a master playlist after this. So in this master playlist, you are going to map this variant playlist. If you don't understand map and all, you can refer to the JavaScript basics video. The link is in the description. And you can get the resolution and everything. And this is where you are creating your final master playlist. So if you can see, this is how it looks like. And this is exactly what I'm doing. Where did my code go? You can see this is exactly what I'm doing over here. I am adding all of this, right? So this is the final code that you have understood. But now let's come to the doc also. So you understood encoding on backend. This is how it is happening. Variant playlist, blah, blah, blah. So master playlist we created, and this is done. So you have understood that how we did the transcoding on the backend, and we tested it using Postman. Now what we want to do is we want to see that we can play this on our client side or not. Now how do we test it? So how we have done so far is all our TS files, M3U8, everything is in this output folder. So for now, just for testing, just for step one, what you can do is you can upload this entire folder in your AWS. So let's try doing that. I'm going to upload a folder. So in HHLT YouTube, let's go to transcoder service. Inside this, there's an output folder. Let's upload the folder as it is. Yes, we want to upload everything. So you can see the TS files, M3U8, everything is going to come. Okay, we are going to add the folder and upload the entire thing. Now that we have added all the files to output, let's come back to the bucket. So here there is output, right? So everything is there. And what do I want to access? The master U8. So if I come over here And if I copy this URL, I should be able to access. The permissions are public right now, so the bucket is publicly accessible. And if you go over here on the client side, what I have done is I've created a video player and I've given one URL, right? So right now, just to fix, like I know everything is hard-coded right now, but this is just to test. So if I go to my video player and I come over here, so I can give one URL over here, right? So right now, let's just give this URL. I'm not sure if it is going to generate the same URL. Okay, so this is the URL, and okay, and what we are going to do is, if HLS is supported, and we are going to attach the video, the source and everything, and we are going to play the video. Okay, so this is a very simple front-end code, but in our page right now, I'm leaving everything else and just adding video player, and I'm going to go to client, and let's try running this. So here you can see the video is getting played, right? And if we go to inspect, and if we go to network and load this again, so can you see M3U8 and TS files? So see, where did this come from? From S3. And the TS files also, see, because we got 1280 by 720, these also came the same. Now, because this is a very small video, I can't show this to you, but in the class we also did. What we did was, we had a huge video. And from there, what we did was, from no throttling, you can change to slow 3G. Now, suppose I do this, and you can see this is still refreshing. Now, later what it is going to do, instead of getting 1280 by 720, it is going to get something else. Now, let's see if it is going to happen. Let's just change quickly, fast 3G, and no throttling. It's going to happen very fast, and slow 3G. I didn't get time. So initially you can say it was 320 by 180, then it switched to 1280 by 720. Because it's a very small video, I was not able to show properly, but you can try uploading for a huge video. I actually showed it in the class. You can try it out yourself because it's going to take a lot of time to show. Essentially, you get the point that adaptive bitrate streaming is happening. So not only we transcoded on the backend, we also saw that how adaptive bitrate streaming is happening on the client. How did that happen? That happened because we used HLS. So we have used HLS.js over here, and if it is supported, we have attached the media loaded source. And if it is not supported, you can just play the original file. The original file is also going to be on the S3. Right now, you will say that, Kirti, for now, what we are doing is we are getting the S3 link. I know, right now, this is how we have done that. What we are going to do is, firstly, we are going to let the upload service upload the entire thing to S3. And in the response of that, if you go back to your upload server, so this is my service. And if I go back to my controllers and multi-part upload, over here, what I'll be doing is that once the upload is complete, I'll be pushing it to Kafka. From Kafka, my transcoder service is going to pick it up. And what am I pushing to Kafka? The location. What is location? The URL. And this is the URL that transcoder wanted, right? The transcoder wanted. So it is going to upload it. And now after this, what you can do is, see, I've added all the steps over here. So HLS streaming on client. Right now, this is hard coded. After this, what you can do is, by the way, I've also added the dash conversion code for reference. If you want to go ahead with dash instead of HLS. Now what you can do is pick up the video from S3, transcode it and push it back. So let's just see this. Then after whole connection, you'll be able to see. Okay. So over in the transcoder service for now. So if we go back to the transcoder service, by the way, if it is getting overwhelming, don't worry. Like if you go step by step, you'll be able to get it. And if you need guidance, you can also sign up for HHLD. We are here to guide you in any way possible. If you can code this out yourself, it is great. If you think, guidance to be able to create projects like this will be useful to you, you can check out the HHLD course. The link is in the description. If you have come so far, you definitely like my teaching style. You're definitely loving the entire project. So if that is the case, if you want to see more projects like this, and if you want to be part of some amazing courses, amazing community where we help each other out, you can check out the HHLD course. Also, the community is so helpful whenever someone runs into any kind of bugs, any kinds of issues, let it be related to AWS or any code, we are here to help each other out. So, yep, that is there. So now let me just walk you through what we are going to do. In our transcoder service, what we had done was that we were transcoding using this convert to HLS. Now we'll be using S3 to S3. What is the difference in S3 to S3 is that here we are going to pick up the URL from S3, transcode it and put it back. So let me quickly walk you through the entire code. Okay, so this is client, this is transcoder service, S3 to S3. Okay, so how we have written the code is that uploader service is going to upload everything to S3, which will be the original file. Once it gets the URL, this URL is given to our service, our transcoder service. You can also do like before the upload itself, the chunking can start, but this is how we have done. Okay, so here we have configured S3 and done all of this. Now what is going to happen is it is going to download the S3 file. Where are we going to get this URL? This URL is going to come from, so if you see S3 to S3 MP4 file name, right? So right now I have hard coded this. You can give this anything. Right now I have hard coded it. What it is going to do is it is going to download the file. And how does it know where to download from? Because we have given the bucket name and we have also given the file name, right? So bucket name and key is enough for it to be able to download. And once it downloads, it is going to create, like you will be able to see, I will run it and show it to you. It will create in its local, it will convert all of it. And after that, it, like you can see, this code is same, right? Resolutions. And from the read stream, we are piping a write stream. And you can see this code is same, right? Resolutions, the for loop, all of this is same. Creating the master playlist, all of this is exactly the same, right? This is same. What we have just done is that till here, it's all good. From here, after we have generated everything locally, we are going to delete it. And then we are going to upload everything to our AWS. And how are we doing that? We are creating one HLS folder and we'll be uploading it over there. Let me show this to you how it is going to run. Right now, the file name that I have added is trial2 because this was actually a very small file. This was just part of one of the classes. So let me just upload the same file for easier purposes. Okay, so let me just go to the HHLD videos and trial2 I am uploading. So this file it is going to find. So ideally what is going to happen is that our uploader service will send this to Kafka. From Kafka, it will pick up the URL location and then it will be able to go ahead, right? For now, we have done like this itself and you can see what all things are there. There's output, there's trial to all of this. We actually don't need output for now, but okay. I'm going to let it be there. And in our transcode, in our index, we have made this change, right? So this is the transcoder service. In our index, we have made the change that S3 to S3 is going to get called. Okay, so just notice what is going to happen over here. So let's go back to Postman. Let's send this request again. And let's come back over here. So can you see this being generated in local? So the files are being generated. And after getting generated, you will see that also deletion will happen. And you can see that logs are coming, right? Because if you go to s3.s3, this is where we were actually adding the logs. And you can see master got generated because it was a small file. It is happening by itself. Now you can see that files are getting deleted. Can you see file getting deleted? Because it deleted locally downloaded S3 MP4 file and now it is uploading the segments to S3, right? So it is deleting everything. So it generates locally and then it is going to upload to S3. So it took the URL from S3 and then it is uploading to S3. You don't even need the entire URL. What do you need? Just the key and the bucket name. So if I load over here, HLS folder is created and inside this you can find everything, right? So this is how you can do from S3 to S3. Now that we have finally seen everything happening, let me quickly show you the final HLD diagram. We have seen all the parts working properly. What you have to do is now code all of this, and I hope from the diagram you will be able to understand exactly what happened, what all you saw. And I know for beginners this can be overwhelming, but my job is to make things easy for you. Coming to the HLD, we drew one client, right? We made one client which was written in Next.js. After that, we created 3 services. One was watch service. The first one that we had created was the upload service. And we also added our transcoder service. Now, what were the requests that went? From where to where did it go? There was one home request that got us all the list of the videos, right? So a client sent home request, which got it all the list of the videos. Upload service, it sent upload. And this was basically 3 API calls, right? One was initiate. So let me write all the 3 calls for further clarity so that you don't get confused. So the first one was initiate. It was upload initiate, but okay. So then it was upload and then it was complete upload, right? So upload / complete it was. So you sent all of these 3 APIs to upload service. Then what happened was between upload service and transcoder service, there was one Kafka. And we also added databases. So there was S3 and PostgreSQL, right? So let's write PostgreSQL over here and S3 over here. So what happened was when we finished up complete, while finishing of the complete, what all things happened was upload service did 3 things. One was that it added the original file to S3. That was one thing. Second thing that it did was it added the metadata to PostgreSQL, basically title, description, and author, and the URL, the S3 URL. Because it had already uploaded to S3, it has the S3 URL. And the third thing that it did was that it added to Kafka and transcoder service consumed from the Kafka. What did it need from Kafka? It needed just the key of the bucket. So the key and the bucket it got. So this transcoder service went to the S3. So it went to S3 and it got the file locally. It transcoded everything and then it put it back. So what service is getting all the details for /home from where? From the PostgreSQL. So these are the things that we have coded. And this is amazing, right? We actually coded everything that is there in the HLD diagram. These are the main features. I know there are a lot more features that you can add. There's recommendation engine that you can add, content filtering, and a lot more things. Major things are like, comment, channel, user table, and all of this you can add. But I guess the main features of YouTube is pretty cool. This is a pretty cool project. What do you guys think? I hope you all had a good time. If you have watched it here, that really means a lot. And I hope you all can be part of EduCourses as well. The link to EduCourses is in the description. We have mentioned all the details on the site, the various courses that we have, the bundles, the curriculums, the testimonials, the FAQs, everything is mentioned on the site. Just check it out. And if you still have any questions, you can reach out to us at support@educourses.com. We would love to be part of your learning journey. And please don't forget to subscribe. I hope you like all the hard work that I'm putting in. Please, you can subscribe. It is completely free for you. Just subscribing, it will motivate me so much. Thank you so much and see you next time. Bye.